Remember, if you get queued up, just click on each day, whatever day it is, and you'll see what we did. Okay? Okay, so that's first one. Some of you guys have already been working on it. Is what? Negative 16, yes. And what's number 2? Positive 16. You guys see the difference? Okay? Here you're doing 2 to the 4th first, and then you take the negative. And the other one is negative 2 times negative 2 times negative 2 times negative 2, which would be positive. And then what do we do down here with number 3? Right, distribute the negative 2. And then we got like terms we can put together, right? Then over here, distribute the 3, right? So we already know how to do that stuff, right? Okay, so we're going to be talking about polynomials today. All right, so those what we just did were some examples of polynomials. Okay, so we're going to identify, evaluate, add, and subtract polynomials. This part, classifying them, is something new, but this first part you probably already knew how to do. And we're going to graph them on our calculator just to take a look at them. Okay, so we're using our graphing calculator today to help us with these polynomials. All right, and then some vocab. Monomial, polynomial, degree of a monomial, degree of a polynomial. You'll know all that by the time you leave today. Leading coefficient, binomial, trinomial, and a polynomial function will be the graphing part where we just put it in our calculator. Okay, so a monomial is a number or a product of numbers. Product means multiply, right? And variables. So we got numbers and variables together with whole number exponents. Okay, our exponents will be whole numbers for these problems right now. A polynomial is a monomial, one term, or a sum or difference of monomials. You could have 2 or 3 or 8. Okay? Each monomial in a polynomial is called a term. Okay? A monomial has only one term. It's the simplest type of polynomial. So a monomial is a type of polynomial. Thank you. A binomial has how many terms? 2. And a trinomial has 3. You guys already knew that, right? Okay. It says polynomials have no variables and denominators. Okay? So there's a variable in the denominator. That's why that is not a polynomial. Okay? Or variables and exponents. So this is not a polynomial. We'll get to stuff like this here. Might even be next chapter. Okay, chapter 7, I think. What?
If the exponent and x is not a polynomial?
If x is an exponent, it's not a polynomial, yes.
So
If y is in the, if a variable is in the denominator, it's not a polynomial.
no, for the second one, where it's like 2 be the third, why is that?
Oh, because it's in absolute value signs. All right, so no roots, no square roots, cube roots, whatever, or absolute values of variables. So there won't be any absolute value signs around our variables or square roots or cube root signs and stuff like that. All variables have whole number exponents. So, I got 4, a 12, a 3, a 7, a 101, a 2, a 3. Those are all whole numbers. You won't have any decimal exponents. It would not be a polynomial if you had a decimal for an exponent or a fraction. Okay? So those are examples of polynomials and some examples of things that are not polynomials. The degree of a monomial is the sum, addition, of the exponents of the variables. So if I have a monomial and I have some variables, I add up all the exponents, and that is the degree of that monomial. Okay? Simple, right? So, Alyssa, what's the degree of this monomial? Oh, you're so smart. Grace, what's the degree of that monomial? Yeah, it's one of those.
0.
Yes, when there's no variable, we call it a constant. The degree would be 0. Because you could write it like this. Anything to the 0 power is what? Guys are killing me. Guys were so smart at one time. What happened to you?
Oh.
Well, hey, girls.
Hey, they were on Starbucks. Huh? Well, she's Where's cheese? Where's cheese?
Oh, yeah.
So this is a pass and not a tardy thing, or what?
Serious?
Really? I want to talk to Mrs. Davis about that.
Ridiculous.
So wait, can you,
Keep going, I'm listening.
can you also write it as, X to the first, at 1 power, because they're like, right?
You could write it, if there's a variable, you could write it as x to the first, yes. If there's no variable, if you were writing the x, oh, I gotta save that. If there's no x like this one, Joey, what are you doing out of your seat?
Oh.
You want me to hurt you? Huh?
No.
Okay, so if there's no variable, okay, there's no degree. Okay, that's like x to the 0. Anything to the 0 power is 1. So that's like 5.6 times 1. Just 5.6, right? So constants, the degree is 0. Okay? What's the degree of this one, Gabe?
Oh.
Letter C. Whoa.
Oh.
Is it just 3 or no? No, it'd be 24. No. Wait.
What did we say, Gabe?
Sorry, I was taking my test.
Yeah, well, I thought you were already. Sum of the exponents of the variable. So what's the sum of the exponents?
What? Oh, it's 4. Yeah, I was gonna say that. Yeah.
4.
I was gonna say that.
4 is the degree. What about the letter D, Hannah? Yes. Okay. So you don't worry about this. We call the numbers in front coefficients, right? So we don't worry about the coefficient. We look at the variables, and then we look at their exponents. If there's no exponent there, 1 is understood to be there, right? So don't forget about that 1. So far, so good?
Yes.
What's the degree of this one, Joey?
3.
You're so smart. What about B, Abigail?
It's 0.
Right. There's no variable, it's
So
0.
smart.
Okay. Kendra, what about C? Yep. And it's because of the 3 and the 2, not because of the 5 in front, right? Audrey, D. Good. We got how to figure out degree of a monomial. Pretty easy, right? All right, the degree of a polynomial is given by the term with the greatest degree. A polynomial with one variable is in standard form when its terms are written in descending order by degree. So in standard form, the degree of the first term indicates the degree of the polynomial, And the leading coefficient is the coefficient of the first term. So this one here, all right, is in the correct order. We call that standard form. Highest degree, that degree is 3, that's 2, that's 1, that's 0. You know, the green numbers there. We put it in order from largest degree to smallest. That's how we want to write our polynomials. Okay? The degree of the whole polynomial is the degree of that first term. So you don't add all these up from the other ones. Okay? The first term's degree is the degree of the whole thing. And then the leading coefficient is that first coefficient. So you need to know how to find the degree of a monomial. If I just separated all those are monomials. If I put them together, I've made a polynomial. You need to be able to tell me the degree of the whole polynomial, the leading coefficient, put it in the right order. How many terms does it have?
4.
4. Good. You can count. Good. You need to know that, be able to do that. And you're going to have to name it also. Okay? It's going to have a special name. Okay? A polynomial can be classified by its number of terms. A polynomial with 2 terms we know is a binomial, and with 3 terms is a trinomial. With 1 term it's a monomial. There's no special name if it's got more than 3 terms. You just say it's a 4, 5, 7, 10 term polynomial. Okay? It can also be classified by degree. So if the degree is 0, we call it a constant polynomial. If the degree is 1, we call it a linear polynomial. If the degree is 2, we call it a quadratic. That's what we just got done having a test on, right? Those were quadratics that we solved. Right? Quadratic polynomials. Joe?
So if like the exponent is like 5, does that mean there's like 4 more x's to make it like 5?
Not always.
Just that chart
But-
shows it like that.
That's how it's showing it, yeah. But, you know, if I had 7x to the 5th minus 1, it's a binomial, but it's still a quintic binomial because it has a degree of 5.
Yeah.
Does that answer your question?
Yeah.
Okay. Yeah, so they don't have to go, if there's an x to the 5th, an x to the 4th doesn't have to be there. A lot of times it is, but it doesn't have to be there. It's still a polynomial. It's still quintic because the degree is 5. Quartic is when the degree is 4. Cubic when the degree is 3. All right, so those are the special names. If it's got a degree of 6 or bigger, you just say 6 degree polynomial, that's all. Or 8 degree.
What if you throw in just like polynomial?
Well, if it asks for the degree, when they ask for a name and it doesn't have a special name, you just take whatever the degree is and call it that. Does that answer what you were asking? Okay, good. Any other questions? All good questions. Okay, so just some terminology that you're learning today. Okay, when we had these, you know, you get stuff like this. Those are equations. When I go y equals x minus 4, it's an equation of a line, right? That's why they call them linear polynomials, degree of 1. We good? Okay. Hannah, you ready? Okay. All right, so put it in the right order, Robert.
This would be 5x squared plus 4x minus 3.
Yeah, don't forget the minus inside in front of the 5. So negative 5x squared. That's the correct order, all right? That's what we call standard form, biggest degree down to the smallest, all right? Then it says, what's the leading coefficient on them? Once you put it in the right order. Negative 5, good. What's the degree, Kendra? 2, right, the highest one you see. Number of terms, 3. So what's its name?
Binomial.
What kind? not cubic,
Double.
quadratic trinomial. Okay, so the right order, all right, leading coefficients, that first one then, once you got in the right order. Degree is the degree of the first term, degree of the whole thing. And you know, you can count how many terms. And then since it's a degree of 2, we call it a quadratic. Since it's got 3 terms, we can call it a trinomial. If it had 6 terms, we would say a quadratic polynomial with 6 terms. There's no special name as far as that goes for a number of terms. Does that make sense? Cameron, what's the right order for B?
8x, 4, 3x, 4.
Good. What's the leading coefficient, Liz? Good. What's the degree, Gabe? 4. Good. How many terms, Tim? 3. Name? Ava? Degree of 4? Yeah. Quartic trinomial, yes. Making sense? Right? All right. Right order. JR?
A,
Yeah, A, sorry.
negative 2x squared plus 4x plus 2.
Good. Leading coefficient, Alyssa? Good. Degree, Isabella? Good. Joey, how many terms? 3. Good. Nate, name it. When it's got a degree of 2, what's the name? Yep, quadratic. Degree of 2, quadratic. It had 3 terms, so it's a, what's a special name for 3 terms? Good. Okay. Mary, right order, standard form.
X equals, minus 18x squared plus 2x minus 5.
Good. That's the correct order. That's called standard form. What's the leading coefficient, Grace?
1.
Degree, Hannah?
Wait.
Degree of the polynomial.
5.
It's the degree of the first term.
Oh,
Just the first term, once you get in the right order. Don't try to add them all up. Okay? We got 4 terms. So what's its name? Autumn.
did you say autumn?
Yep.
Oh,
Damn.
the first kid's name.
Go by degree.
Oh.
Not how many terms.
Why do we go by degree?
That's how you look.
Why do we go by term?
You don't go by terms, you go by degree as far as the first part of it. Okay? These go with degree. All right? So it was a degree of 3, right? So it'd be cubic polynomial with how many terms?
4.
4. So that one was more than 3. It's not a trinomial, not a special name. Once it's above 3, just say how many terms it's got, or number of terms. All right? I expect you to be able to do that type of problem now. Joe, you got a question?
What's it go, binomial?
Trinomial and then monomial for one,
Oh.
binomial for two, trinomial for three, and then after that, you just say how many terms it is. There you go.
What was after three? Are we just gonna do the polynomial with?
Yeah, like this one, polynomial. Would we say quintic polynomial with 4 terms? Not quintic, cubic, right? All right, add or subtract, combine like terms, so go ahead, Liz. Add. Are you Liz, Joe? You know you got long hair?
I mean,
Thank you. Well, 13 will be down at the bottom end. All right, let's put it in the right order. That's how it should look when you're done. Let's name it, Isabella. You did what I did. 3 is not a 5. 5 is quintic. 3 is, yeah, cubic. All right? Polynomial with 4 terms. How about this one, Alyssa?
Negative 3x squared minus x, or plus x, and then plus 9, or negative minus 3.
So the negatives, that minus basically turns those to the opposite, right? So we got negative 2x squared minus 1x squared is a negative 3x squared. Minus a negative x is like plus x. 3 minus 6, negative 3. Put it in the right order. You guys can handle that, right? You knew that. You knew how to do this first day of school, right? You should have. Okay. Do I need to do another one?
yeah.
Okay, go ahead, Gabe.
Oh, bruh.
What's first?
It'd be negative 30. Oh. Oh yeah, 16 after the third. And that'd be negative 3 x. Yup. And then it'd be 6x. And then or minus 6. 17. Yeah. Oh, it's 16. 18, yeah. 19.
We good? Go ahead.
5x squared. Eight. What would that be?
One more than 8.
9. Plus 3x. Oh, minus 3x.
I'll do it.
14.
Very good. Plus 14. We okay? I'm okay.
Are you?
Yes, I'm fine. When you guys get a wrong answer, I don't feel so. We okay now? Right, we can handle this, right? Okay. What about this problem? The cost of manufacturing a certain product can be approximated by that function. X is the number of units of the product in hundreds. So evaluate f of 0 and f of 200 and describe what the values represent. So when it says f of 0 and f of 200, what am I supposed to do? Just plug them in, right? Okay, so what are these numbers describe, describe what's going on, here, what that represents? So they're manufacturing these things. So basically it costs how much?
45.
45, right? Well, actually it would cost more than that, whatever one is, but, 3 minus 18 is negative 15, so it'd be $30 per one, right? So this is 200, is that 200 units or more than 200 units? More than 200, 200, 100. So I gotta add 2 zeros. What's 200 plus adding 2 zeros to it? 20,000, yeah. So that's 20,000 units cost how much? Almost 24 million, yeah. Okay. All right, so just something to think about. No big deal. All right, throughout this chapter, you will learn skills for analyzing, describing, and graphing higher degree polynomials. Until then, we're going to use the graphic calculator. So, how do I put this in my calculator to look at the graph? What's the button I got to push first? The y equals. Oh, I already hit it. Okay, the y equals button gives you this, right? Now, 2 is right here, right? X is right there, the second row in the middle, next to alpha, between alpha and stat. That's the X button. To get it to the third power, it's your caret button right above division. And then 3 minus 3x, hit enter, and then hit graph. See if you get that.
I don't know how to get down.
Wait, what?
See if you get that. Can I do the what thing again?
Oh,
It's like going to the pen.
oh, I got it.
Wait.
Y equals button. You hit that, Hannah?
Yeah.
Okay.
Wait.
How do I get
Why
back
did you
down?
do a squiggly thing in the middle?
Okay. So hit your 2 then, right?
Where?
You see where the X is?
I got it.
Okay, you got your X. Caret is right above division. You got that spot? All right. Then 3 minus 3x. Hit enter, then hit graph. Anybody's not showing up?
I got it.
Get like dimension mismatch or something. Anybody getting that? Good. All right, clear, hit clear, go back to your y equals, hit clear. Now how am I gonna put negative 1/6 in this calculator? We'll put it in parentheses though. So put your parenthesis right above the 8, left one. Negative is down here, very bottom under the 3. And put 1 divided by 6, parentheses. There's your 1/6. Okay? And then what is it? X to the 4th. So X caret 4 plus 2x. You can go caret 2, or this is the squared button here on the left side. I usually hit that for squared. And then minus 2, not negative 2, but minus 2. Hit enter, and you should have a M when you do it.
I just got. I got an upside down U.
Then you forgot your negative 1/6.
Oh, I got
You do the 4th instead of the second power. Okay, should be x to the 4th, Joey.
I did.
Okay, should look like this. Okay, what's the degree of the first polynomial we put in? 3. And what's the degree? You forgot the x. What's the degree of the second one we put in? 4, right? How many times did the first one cross the x-axis?
3. Oh, 3.
Like the first one?
The first one,
Oh, three.
3 times, right? And what was the degree again?
Three.
No, what was the degree of the first one we did? Degree is 3, right?
Oh, so the
How many times did it cross?
three.
3. What's the degree of this? How many times did it cross? Okay? That happens 90-something% of the time. Not every time, but the way they describe the graph, then they say you always describe it from left to right. So it increases, and then it decreases, and it increases, right? Okay? It crosses the x-axis 3 times, so there's 3 real zeros. If we were trying to solve this, wherever your graph crosses the x-axis is your answers. Those are your zeros or your roots. Okay? This one, left to right increases, decreases, increases, decreases. It crosses 4 times, so it's got 4 real zeros. Okay? That happens, like I said, over 90% of the time. Sometimes, I'll just show you. You guys can put, if you want to put those in, you can to see if it looks like what you want, but you don't have to. But sometimes, you think it should cross how many times? 2, but does it? No. Sometimes that'll happen. It won't cross at all. It'll only hit once when you're thinking it would hit twice because the degree was 2. So there's no real zeros because it doesn't cross the x-axis. There's 2 non-real zeros. If I were doing my quadratic formula, what kind of number would be under the radical sign? Since it's non-real. Not positive. A negative number, right? That's when we start pulling the i's out, right? The letter I, our imaginary unit for our non-real answers. Okay? So you might have to do a couple of those problems where they'll want you to graph it, sketch a graph. You just put in your calculator, okay? So you can look at it. So those problems aren't really tough. And that's it for the day. Good job. Hopefully by tomorrow this time I'll have your test graded for you. Okay?
Go Weavers.